Okay, today we're going to talk about scatter plots and trend lines. So if you're on the video and you're watching this, take a moment, please pause the video and write down just this title in your notes. Okay, so the big idea for today, we're going to create a line of best fit model, a linear relationship, and use it to make predictions. Okay, so in math we could see if two things are related using a scatter plot and using a line. Okay, so and we're going to be a little bit more analytical, so we have to think about the concept of relationships. Okay, so I got a question for you. Does shoe size affect how fast you run?
No.
Talk to your neighbors about it. Say yes or no.
Yeah.
Why or why not? Okay, who says yes, it does affect it? Okay, why, Jaren?
Because like when pick your feet up and if it's too big, then like your foot could drag.
Oh, so you're saying that a bigger foot slows you down?
Yeah.
Okay, so a smaller feet makes you faster? Is that what you're saying?
Yeah, I guess.
Okay, cool. Who else says yes, it affects it? Okay, who says no, it doesn't affect it? I heard a lot of no's. Eli.
Huh?
Yeah, why?
Well, it doesn't really matter because I know big people with big shoes that are so fast,
Oh, yeah.
and I know like small guys with small feet are still fast. I think it's just somewhat like it depends on how fast they are in general. I don't think it matters about shoe size.
Okay. Cool, those are good arguments, okay? Alright. Now, if I were to line up every person in the US from the smallest shoe size to the biggest shoe size, okay? All the little babies with a little cute little feet, you know. Okay? And I'm gonna figure out how fast the little baby run. Not very fast because they could barely walk, right? And I'm gonna take the biggest footed guy. Okay, and I'm going to figure out, don't you agree that generally speaking, that people with smaller feet are going to run slower than people with larger feet? Right? So am I right that generally speaking there is a relationship between shoe size and speed? Right? Generally speaking, yes. Is it a strong relationship? No, generally speaking, yeah, there's a somewhat of a relationship, right? Little kids with little feet, like little kindergartners that may have a size 2 or 1 or 3, I don't know what size they have, okay? They're going to run slower than you, and you kids all have like what, size
13.
6 to 13, okay? Or 5 or 4, I don't know. But you definitely have bigger feet than a kindergartner. Would you agree with that? Yeah, so generally speaking, yes, there is that relationship. Now listen up. Does your foot size cause you to run faster? Does foot size cause faster running? No, because you could have what Eli said. You could have this really big-footed person, and they could run slow, right? Would you agree with that? What if you were a really big-footed person and you were also like really obese, like 600 pounds, right? Are you gonna run fast?
No.
No. Okay. What if you're a little person with little feet? Could you run fast? Yeah, you can run really fast. There's some really fast students on here on this campus that have smaller feet than the average, okay? You're already naming names, right? Does that make sense? Good. Okay, so we're going to talk about relationships. So what I'd like you to do now, if you're in the video, please write this down. Please pause the video here and write this down. So, next one. Next slide. I'd like you to look at these points. Okay, so in math, we can look at graphs. This is called a scatter plot. Okay, let's say I interviewed these students. We got 1, 2, 3, 4, 5, 6 students, okay? I asked them, hey, how long did you study? Because I want to know if studying time affects your test score, okay? Because I think that studying time is an independent variable and that it could affect the dependent variable, which is test scores. So I asked the student, I said, hey, how long did you study? One student said, hey, I studied 3 hours. And so they scored a 67, right? Another student studied 2 hours and they scored a 62, right? Someone else also studied 2 hours and they scored higher. You see that? So did you notice that these two students have like the same study time, but they scored different? Y'all see that? And then you have the student here studied a little bit longer. This student studied even longer and got a higher score. And this student studied the longest and got the highest score. So, what do you notice? Turn to your neighbor. Tell them what do you notice about this graph. Is there a relationship? Looking at this graph. Okay, go. Everyone's talking to the neighbor. 10 seconds, 15 seconds. What do you think? What do y'all think? So, do you think there's a relationship between studying time and your scores? What do y'all think? I would say, yeah, there is, right? Don't you notice that the less time you study, you have more people with less time that have a lower score, and then there's more study time up here? Ryan, keep your hands to yourself, okay? I know you want to turn back and stare at your neighbors. Okay? And I want you to focus on lesson. Shh. Listen. Okay, so I could draw a line here, right? And this line kind of shows the trend, right? I could see that the less time you spend studying, the lower you're going to get. I could predict that, right? What if someone studies like for 6 hours? Can't you predict that they're going to make, or that they're going to get a really high score? Does that make sense? Now I got a question. Does studying cause higher scores?
Yes.
I would say yeah, it does, okay? Does it guarantee a higher score though? No, because you see, the relationship is there. Studying does cause a higher score, but that doesn't necessarily guarantee a higher score. Just like this person studied for two and a half hours, didn't get a high score, but the same person studied 2.5 hours, got a higher score. Y'all see that? Okay, good. So causation, super important, because you don't always want to say like, oh, these are related because one thing causes the other, right? Just like I said earlier, that a larger foot is related to faster running speed. Does a larger foot cause faster running? Yes or no? Larger feet cause faster running? No, because who has largest feet? Ryan has a 13? Does anyone have a larger than a 13? Is there anyone faster than Ryan in here?
Yes, like a lot of people.
Okay. Carly, what size are your feet, Carly? An 8, right? So an 8 is faster than a 13, right? So we know that, generally speaking, larger feet is related to faster running, but does it cause faster running? No. Okay? Good. Sorry, it's a lot of concepts here. Okay, so here's the next thing. This is what scatter plots look like. Scatter plots are a graph that compares the relationship between two variables. We've been looking at them. You could either have a positive relationship, that you have a line that's going up. You see this is called a positive relationship, or we could call it a direct relationship. Or you could have a negative or indirect relationship, right? Or you could see this last one. You see this one? Is there any line I could put through this last one? No, I can't. I could try to put a line like that way or this way, but there's not really, or I could try to do that, but that doesn't work. I want a line. So that's called no relationship. Oh, okay. So, next one, the correlation, a definition is how strongly one variable, the independent variable, is related to the dependent variable. And then we have this thing called R value we're going to calculate tomorrow on our iPads. R value is super important to understand. It's a number between -1 and 1. What's the number in between -1 and 1? 0, okay? So, like, when our R value is -1, it means there's a really strong negative relationship, okay? Or if it's closer to 1, it's a really strong positive relationship. You see how I'm shaking because it's strong? And when the number gets closer to 0, it's not strong. It's weak. Does that make sense? So when the number gets closer to negative, really strong. 0, positive. Okay? What's wrong? Whatever. Did you guys and girls get the point?
Yes.
Okay, that's all I care about. Alright? Thanks. Okay. And then there are these 3 graphs I showed earlier. So I'd like you to do it now. Please pause the video. I'd like you and all the students in here, please write what I highlighted, R value. These 3 numbers, -1, 1, 0, and the 3 graphs. It's going to take you a couple minutes here, so I'm going to pause the video here. Let's keep going here. So, Oh, I'm sorry. That's not what I want. That's number 3. That's the answer to number 3. Here we go. Number 1 and 2. Okay? Okay, so let's just say that I'm going to show you a couple of them, okay? The directions here is what type of correlation is the following? Does the independent variable cause the dependent variable to happen, okay? Okay, make sure your hands are to yourself, okay? So, on number 1, I'm trying to, let's say I'm a doctor, okay? And I'm in my med school program, and I just wanted to do a new study on sun exposure and the number of moles my patients have, okay? Right? So, I think that's really important for doctors to know, right? We want to know, like, and for people to know, too, because it's like, do I want to have a bunch of moles on my body, right? Or do I want to have any malignant moles? So, I ask a person, how long have you been in the sun? On average, how often are you in the sun all week? And they tell me, oh, I'm like 5 hours. So they're like, and how many moles you got? And they're like, I got like 15 moles, okay? And then I ask someone else, how long are you in the sun? And they're like, oh, I'm only in there like maybe 10 minutes for the whole week. I try to stay out of the sun, okay? I even wear a mask. I wear one of those shady things and a hat. And in the car, my car is tinted, and I'm never outside. How many moles you got? I only have one tiny mole on the back of my neck. Okay, cool. And then I asked, and then the doctor's like, how many hours are you in the sun? I'm in the sun all day. I'm in the sun from sunrise to sunset. How many moles do you got? Oh, you could see them. There's hair growing out of them. There's like 35, 40 of them. Okay? I like moles because I like twirling the hairs out of my moles. Wow. Okay. Hey, don't be hating. I like storytelling. Okay, so.
That's a good story.
Anyways, as a doctor, I want to make sure that I want to communicate the right things to my patients because, I don't want patients to get sick if they don't need to get sick, okay? So, or have cancer. So, looking at this, do you all see how that there's a pattern of all the dots? You notice how they're all together and they're all pointing up? Do you all see that? I could draw a line here. This could be a line this is called the line of fit, right? You see how all the dots are close to this line and they're all close together? Since it's going up, we say it's a positive direct relationship, okay? And since all the dots are close together, we also say that the R value is close to 1. Okay? And now, number 2, sorry, I went ahead of myself here. Number 2, okay? Oh, wait, number 1, the next question I got to ask myself, does the independent variable cause the dependent variable to occur? Okay, so I got a question. Does sun exposure cause moles?
Yes. No.
Yes.
It causes sun kisses.
Causes kisses?
Sun kisses. My grandma calls
Oh,
it
sun kisses. What do you think? Yes or no? Okay, and that's a debate that doctors could have. I would say that yes, from the data it causes it, okay? But some people say no, it's genetic, okay? So maybe if I was a doctor trying to prove no, it's not genetic, it is actually related to you being out in the sun, then I would say yeah, it is related. Okay, does that make sense? Why is it important to know if it's causing moles? Why would someone want to know that sun exposure causes moles? For research, but why?
Cancer.
If they don't want moles, they don't want cancer. Does that make sense? Wouldn't you want to know? Right? What if like sun exposure doesn't cause moles? Would you care if you went out in the sun? No, you wouldn't care. Does that make sense? Number 2, engine size and miles per gallon. Let's say I was researching. Let's say it's my first car here. Let's say I'm your age, okay? Okay, and I'm like, hey, you just start asking your friends, hey, what size is your engine?
V8.
No, like liters, okay? So good. That's part of it. So of course the V8's gonna have more liters, okay? So let's just say I ask you, Damien has his car. He's like, how many miles per gallon? Damien has a sweet ride. It's a V8. It's okay. Okay. So Damien says, hey, I get 15 miles per gallon in my V8. It's a 4.7 liter, which is like right around here, right? And then I ask like someone else, they drive a motorcycle to school, and they get like really high gas mileage. And then someone else is like, oh, I have a small engine. It's a Prius, but I get really high gas mileage. What's so funny? I don't get it. Okay, I don't get it. Okay, anyways, and then there's someone that has a big truck, right? It's really too big, but it's like it gets no gas mileage. It gets like you push the engine and it's like it's very, or you go and you use a lot of gas. Okay, does that make sense? So I ask all the people out in the parking lot, all my friends, because they're like, I'm getting my new car. I want to figure out if there's a relationship. Okay, so I plot all these points. Do you see a relationship? Yes or no? Yeah, definitely. Do you notice that we have a relationship that is negative here, right? As engine size gets bigger, what do you notice about miles per gallon? It gets smaller, okay? Please don't throw papers on the floor. Please pick that up. Okay? There's a couple of them on the floor over there. Thank you for doing that. All right, so now I got a question for you. Now I got a question for you. Thank you for picking that up. Are my dots close together, yes or no? Yeah. So we would say this has a negative indirect relationship. So the R value is closer to -1, right? Really strong relationship, and it's indirect. Okay? Does that make sense, everyone? Yes? Okay, good. So what I'd like you to do is discuss how we read a graph and we're able to identify if there's a relationship or not. Ready, set, and go. Go in here. Let's go to number 3. Number 3 and 4, discuss with your neighbors. I want you to tell me what kind of relationship is there and does one thing cause the other thing to happen. Okay, go. Okay, good. If you can hear me, clap twice. Good, thank you. So number 3, is there a relationship between studying at night and GPA? Yeah, we could draw a line. Can't you draw a nice little line there? So we're going to say that's positive, direct relationship. What about your R value? Do you think are those points really close to that line, or are they kind of spread out a little bit?
Pretty close.
They're pretty close, but are they more spread than the other problems? Yeah, so I'm going to say that it's a weaker relationship, so our R value is going to be farther away from 0, or farther away from 1. It's not going to be that strong relationship, it's going to get closer to 0 and become weaker, okay? Alright, does that make sense? Alright, good. Next one, number 4. Is there a relationship there between shoe size and reading ability? Now I want you to know that these points are kind of legitimate, right? A little baby with like mini feet, right? Size 1. Can they read at all?
No.
No. Okay. And then, you get up to high school, you can read a lot better. Some of you have size big feet, size medium feet. Okay. You read pretty well, right? So is there a relationship here? Yes or no? Oh. Is there a relationship? Yeah. Now I got a question for you. Shh. Braden, good singing. Thank you. Like this video if you like Braden singing. What?
This video is gonna go viral.
Okay.
Sorry, can you pause the video whenever you yell at one of us?
Nope. Okay, so that's why you have to be careful.
Oh, okay.
I won't say your last name though. That's why. So over here, do you notice how all these points are far away from this line? So is it a strong relationship?
Not really.
Not really. But there is somewhat of a relationship. Now I got a question. Does your shoe size cause you to read better?
No.
You're like, man, I wish I had big feet like Ryan.
Some people still
He's such a good reader.
So
No. Does that make sense? Generally we could say, yeah, there is a connection between shoe size and your reading ability because, duh, when you grow up, you should be reading better, right? Okay, cool. So let's practice this. Let's pretend we collect some data on cars. Okay, so let's pretend you went out there. Again, this is the data. So what I'd like you to do on your notes, let's all create an X and Y axis like this one, and then we're going to do this together. Okay. Okay, so X-axis always represents the independent variable. So I'm trying to figure out, does engine size affect my gas mileage? Does that make sense? Does it affect it? Is it related? So on the bottom, I should put engine size. So let's all write that down, engine size, and then on my y-axis, I'm going to write down miles per gallon, okay? And I want to neatly make a nice scale of engine size. So I'm looking at, what's the smallest engine size that's up there, everyone? How many liters is the smallest engine size? Liters is volume, by the way. Just like a Coke is 2 liters, it's 2 liters of Coke.
1.2.
1.2, good, okay. What's the largest?
5.7.
5.7, okay. So maybe I'll go from like 0 to like 6. Does that make sense? So I'll make this 0, and then I'll neatly write down the numbers from 1 to 6. Y'all see that? You see how neat that looks? You see how they're evenly spread? Yes?
Yes.
Okay. Now, on miles per gallon, what's the smallest miles per gallon that you could get? 1.2. Okay, what's largest? 5.7. What's the smallest you could literally get? Let's say pedal to the metal. What's the smallest? 0, right? Couldn't you just waste gas like just by flooring it all the time? Theoretically, right? So let's go from 0 up to, what's the largest? 5. So I'm going to just draw out my scale. I'm going to go up to my 40 miles per gallon. I'll go up to 50, okay? And then I'm going to plot these, right? The first one says 1.2 liters, 40 miles per gallon, so I'm going to plot a point. Next one is 4.6, 14 miles per gallon, which is over here. Okay? Next one is 2.8 liters, 27 miles per gallon. Okay, now I keep plotting all of these, and then I'm noticing, hey, look, is there a trend? Do you see a trend up here, everyone?
Oh, yeah.
Yes or no?
Yeah.
Yeah, definitely, right? We could definitely see there, and I could make a line, a best fit through this, like, and I'm noticing, hey, this is going down, it's negative, so it has to be indirect, right? It means as engine size gets bigger, what's happening to my miles per gallon? As engine size gets bigger, what's happening to miles per gallon? It's going down. Inverse. You see how it's going the opposite direction? Whereas before we were talking about direct relationship. Okay, cool. So we'd write that. And we could say, hey, since the points are close, we could say that R value is equal to 1. Okay, so it's negative indirect relationship. R value is equal to negative 1. Okay? Is this hard? Yes or no? No. It's, you're being a little bit more analytical about it, but it's not very difficult. All right, that concludes the lesson. So what I'd like you to do now is you're going to be working on this workbook, pages 1 through 4.